When wiring general living areas or bedrooms in a home, it's essential to understand the maximum number of receptacles or lights that can be safely connected to a 15 amps or a 20 amps breaker. For a 15 amps breaker, the maximum number of receptacles is up to 12. For lights on a 15 amps breaker, the maximum is up to 10. If you are using a 20 amps breaker, you can connect up to 20 receptacles. As for lights, a 20 amps breaker can handle up to 15. It's very important to consider that these figures represent the absolute maximums. The actual allowable load on a circuit may be lower, depending on several factors. These include the wiring methods used, the type of fixtures, and the appliances connected to the circuit. Always consult local building codes and electrical regulations for the specific requirements in your area. These codes are put in place to ensure safety and prevent electrical hazards. General recommendations advise installing at least one outlet every 6 feet along the perimeter of a room. This helps ensure convenient access to power without relying on extension cords. It's also recommended to have at least one light fixture per room to provide adequate lighting. Always exercise common sense to avoid overloading circuits. Overloading occurs when too many high wattage devices or appliances are connected to a single outlet or light fixture. This can cause the breaker to trip, interrupting the power supply. In severe cases, it could lead to overheating and potentially start a fire. To prevent overloading, calculate the total wattage of all devices connected to a circuit. Ensure that the total wattage does not exceed the capacity of the breaker. A 15 amp circuit at 120 volts can handle a maximum of 1800 watts. This is calculated by multiplying 15 amps by 120 volts. A 20 amp circuit at 120 volts can handle a maximum of 2400 watts. This is calculated by multiplying 20 amps by 120 volts. It's good practice to stay below 80% of the maximum capacity to provide a safety margin. This reduces the risk of nuisance tripping and extends the lifespan of the breaker. When calculating the load, consider both continuous and non-continuous loads. A continuous load is defined as a load that operates for 3 hours or more at a time. For continuous loads, the breaker should be rated for at least 125% of the load. This means that a 15 amps breaker should not be subjected to a continuous load exceeding 12 amps. A 20 amps breaker should not be subjected to a continuous load exceeding 16 amps. Various wiring methods are used in residential electrical systems. These methods affect the ampacity of the conductors, which is the maximum current they can safely carry. Common wiring methods include non-metallic sheath cable, often called NM cable or Romex, and electrical metallic tubing, often called EMT. The ampacity of conductors depends on their size, insulation type, and the ambient temperature. The National Electrical Code, known as NEC, specifies the allowable ampacities for different types of conductors. Ensure that the conductors used in a circuit are rated for at least the overcurrent protection provided by the breaker. Using undersized conductors can lead to overheating and fire hazards. When connecting fixtures and appliances, ensure that they are properly rated for the voltage and current of the circuit. Using fixtures or appliances that are not rated for the correct voltage can damage the equipment or create a safety hazard. Pay attention to the wattage rating of light bulbs. Do not exceed the maximum wattage specified for the light fixture. Using a bulb with a higher wattage can overheat the fixture and potentially cause a fire. Consider using energy-efficient lighting, such as light-emitting diodes, known as LED. LED consumes significantly less power than incandescent or halogen bulbs, reducing the overall load on the circuit. When installing receptacles, use tamper-resistant receptacles, known as TRR, in areas where children are present. TRR have internal shutters that prevent children from inserting objects into the slots, reducing the risk of electrical shock. Ground fault circuit interrupter, known as GFCI, protection is required in certain locations, such as bathrooms, kitchens, and outdoor areas. GFCIs detect ground faults and quickly interrupt the power supply, protecting against electrical shock. Arc fault circuit interrupter, known as FSI, protection is required for circuits supplying receptacles in bedrooms and other living areas. A size detect arc faults, which are dangerous electrical arcs that can cause fires. The NEC provides detailed requirements for the installation of electrical systems in residential buildings. It covers topics such as wiring methods, grounding, overcurrent protection, and appliance installation. Adhering to the NEC helps ensure the safety and reliability of the electrical system. Many local jurisdictions adopt the NEC with amendments or modifications. It's important to be familiar with the specific requirements in your area. Local building inspectors enforce the electrical codes and regulations. They inspect electrical installations to ensure that they comply with the applicable codes. Obtaining permits for electrical work is often required. Permits allow the local authorities to track electrical installations and ensure that they are inspected. Working without a permit can result in fines and require the work to be redone. If you are not comfortable performing electrical work yourself, hire a qualified electrician. A licensed electrician has the knowledge and experience to safely and correctly install electrical systems. When hiring an electrician, verify their license and insurance. Ask for references and check their online reviews. Obtain a written estimate before starting any work. The estimate should include the cost of materials and labor. A detailed contract should be signed outlining the scope of work, payment terms, and warranty information. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the breaker and preventing electrical shock. The grounding system should be properly connected to a grounding electrode, such as a ground rod or a metal water pipe. All metal enclosures and equipment should be bonded together to create a low impedance path for fault current. Surge protection devices can protect sensitive electronic equipment from voltage surges. Surges can be caused by lightning strikes, utility switching, or internal events. Surge protectors divert excess voltage to ground, preventing damage to equipment. Smoke detectors are required in all bedrooms and on each level of a home. Smoke detectors provide early warning of a fire, allowing occupants to escape safely. Carbon monoxide detectors are required in homes with fuel-burning appliances or attached garages. Carbon monoxide is a colorless and odorless gas that can be deadly. Regularly test smoke detectors and carbon monoxide detectors to ensure that they are functioning properly. Replace the batteries at least once a year, or according to the manufacturer's instructions. When replacing receptacles or switches, use devices that are listed by a recognized testing laboratory, such as Underwriters Laboratories, known as UL. UL listing indicates that the device has been tested and meets safety standards. Do not use extension cords as a substitute for permanent wiring. Extension cords are intended for temporary use only. If you need additional outlets, install permanent wiring. Avoid running extension cords under rugs or across walkways. This can create a tripping hazard and damage the cord. Do not overload extension cords. Check the wattage rating of the cord and do not exceed it. Use heavy-duty extension cords for appliances that draw a lot of power. When working on electrical circuits, always turn off the power at the breaker. Verify that the power is off using a voltage tester. Wear safety glasses and insulated gloves when working with electricity. Be aware of the location of underground utilities before digging. Contact the local utility companies to mark the location of underground cables and pipes. Maintain a safe distance from overhead power lines. Do not use ladders or other equipment that could come into contact with power lines. Be careful when working in damp or wet environments. Water can conduct electricity and create a shock hazard. Use ground fault circuit interrupter protection in wet areas. If you experience an electrical shock, seek medical attention immediately. Electrical shock can cause serious injuries even if you feel fine. Learn cardiopulmonary resuscitation, known as CPR. CPR can help save a life in the event of an electrical shock or other medical emergency. Keep a well-stocked first aid kit on hand. The first aid kit should include bandages, antiseptic wipes, pain relievers, and other essential supplies. Store flammable materials safely away from electrical equipment. Flammable materials can ignite if they come into contact with hot electrical components. Inspect electrical cords and plugs regularly for damage. Replace damaged cords and plugs immediately. Do not attempt to repair damaged cords or plugs. Keep electrical panels and equipment clean and free of obstructions. Dust and debris can accumulate and cause overheating. Make sure that electrical panels are properly labeled. Label each breaker with the circuit it controls. This will make it easier to identify and shut off the power to specific circuits. Keep a record of all electrical work that has been performed. The record should include the date of the work, the name of the electrician, and a description of the work that was performed. Store the record in a safe place. If you have any questions or concerns about electrical safety, consult a qualified electrician. Electricity is a powerful force that can be dangerous if not handled properly. By following these safety tips, you can help protect yourself and your family from electrical hazards. Remember that the maximum number of receptacles and lights allowed on a breaker is just one factor to consider when wiring a home. It's also important to consider the total load on the circuit, the wiring method used, and the local building codes and electrical regulations. By taking these factors into account, you can ensure that your electrical system is safe and reliable. Remember that the NEC is updated every 3 years, and local codes may have their own specific modifications or additions. Always consult the latest version of the NEC and local codes before starting any electrical work. Furthermore, it is imperative to understand the difference between a branch circuit and a feeder. A branch circuit is the circuit conductors between the final overcurrent device protecting the circuit and the outlet or device. A feeder is all circuit conductors between the service equipment or the source of a separately derived system and the final branch circuit of a current device. The calculations and considerations for feeders are more complex than for branch circuits, as feeders must be sized to accommodate the total load of all the branch circuits they supply. Consider the use of energy monitoring systems to track energy consumption and identify potential problems. These systems can provide real-time data on voltage, current, and power consumption, helping to optimize energy use and prevent overloads. When installing new electrical equipment, choose energy-efficient models. Energy-efficient appliances and devices consume less power, reducing the overall load on the electrical system and saving money on energy bills. Consider the impact of future electrical loads. As technology advances, the demand for electricity in homes is likely to increase. Plan for future needs by installing additional circuits or increasing the size of the service entrance. Consider the use of smart home technology to control lighting, appliances, and other electrical devices. Smart home systems can automate energy management and provide remote control over electrical devices. When installing recessed lighting, ensure that the fixtures are rated for insulation contact, known as IC. IC-rated fixtures can be safely installed in contact with insulation without creating a fire hazard. Use caution when working around aluminum wiring. Aluminum wiring was commonly used in homes built in the 1960s and 1970s. Aluminum wiring can corrode and loosen over time, creating a fire hazard. If you have aluminum wiring, have it inspected by a qualified electrician. Consider replacing aluminum wiring with copper wiring. Copper wiring is more reliable and less prone to corrosion. Use wire connectors that are specifically designed for use with aluminum wiring. These connectors are designed to prevent corrosion and maintain a secure connection. When splicing wires, use proper wire connectors. Do not use electrical tape alone to splice wires. Wire connectors provide a secure and reliable connection. Ensure that wire connectors are properly sized for the wires being connected. Using undersized connectors can create a loose connection and a fire hazard. When pulling wires through conduit, use a wire lubricant. Wire lubricant reduces friction and makes it easier to pull the wires. Do not overload conduit. Conduit fill requirements are specified in the NEC. Overloading conduit can damage the wires and make it difficult to pull them. When terminating wires at receptacles, switches, or breakers, use the proper torque. Over-tightening or under-tightening terminals can create a loose connection and a fire hazard. Use a torque screwdriver to ensure that terminals are tightened to the correct torque. Inspect electrical systems regularly for signs of wear and tear. Look for frayed wires, cracked insulation, loose connections, and other potential problems. Address any problems promptly to prevent electrical hazards. Consider having a professional electrical inspection performed periodically. A qualified electrician can identify potential problems that may not be visible to the untrained eye. Keep electrical panels and equipment accessible. Do not block access to electrical panels or equipment with furniture or other objects. This will allow for easy access in the event of an emergency. Ensure that electrical panels are properly ventilated. Overheating can damage electrical components. Provide adequate ventilation to prevent overheating. Be aware of the dangers of static electricity. Static electricity can damage sensitive electronic equipment. Take precautions to prevent static electricity when working with electronic equipment. Consider using a whole-house surge protector. A whole-house surge protector protects all of the electrical equipment in your home from voltage surges. Consult with a qualified electrician to determine the best type of surge protection for your home. Consider using a backup generator in case of a power outage. A backup generator can provide power to essential appliances and equipment during a power outage. Ensure that the backup generator is properly installed and maintained. Follow the manufacturer's instructions for safe operation. Consider using uninterruptible power supplies, known as UPS, for sensitive electronic equipment. UPS provide backup power in the event of a power outage, preventing data loss and equipment damage. Be aware of the dangers of ground loops. Ground loops can cause noise and interference in electronic equipment. Take precautions to prevent ground loops. Consider using isolated ground receptacles for sensitive electronic equipment. Isolated ground receptacles provide a separate grounding path for the equipment, reducing the risk of ground loops. Be aware of the dangers of electromagnetic interference, known as EMI. EMI can disrupt the operation of electronic equipment. Take precautions to minimize EMI. Consider using shielded cables and enclosures to reduce EMI. Be aware of the dangers of radio frequency interference, known as RFI. RFI can disrupt the operation of electronic equipment. Take precautions to minimize RFI. Consider using filters to reduce RFI. When installing electrical equipment in hazardous locations, follow the requirements of the NEC. Hazardous locations are locations where flammable gases, vapors, or dust are present. Special equipment and wiring methods are required in hazardous locations. Be aware of the dangers of electrical shock. Electrical shock can be fatal. Take precautions to prevent electrical shock. Avoid contact with energized electrical circuits. If you are not qualified to perform electrical work, hire a qualified electrician. Electricity is a powerful force that can be dangerous if not handled properly. By following these safety tips, you can help protect yourself and your family from electrical hazards. These guidelines offer a starting point, and it is imperative to consult the most recent version of the National Electrical Code, often referred to as NEC, and local building codes to ensure compliance and safety. The NEC provides comprehensive standards and regulations for electrical installations, while local codes may have additional requirements specific to your area. Consulting with a qualified electrician is highly recommended, as they possess the expertise and knowledge to ensure that your electrical work is performed safely and in accordance with all applicable codes and regulations. Ignoring these guidelines and codes can result in serious safety hazards, including electrical shocks, fires, and equipment damage. Prioritize safety and compliance when working with electrical systems to protect yourself, your family, and your property.